The goal of this project was to produce 3 species, a legged, wheeled, and wagged robot, to test the effectiveness of these locomotive methods in smooth and rough terrain, comparing these effectivenesses to see which one crosses the reality gap best. The method was to test each of these 3 species in a rough terrain setting and a smooth terrain setting, using a flat generated terrain for the smooth and this 3-tiered box for the rough terrain. A position sensor was placed in the body, and forward distance, read off by the position sensor, was the fitness. The results: random tests concluded in either instability, the legged and wagged robots falling over, or any of the 3 species not making it out of the square in the rough terrain setting. This setting was seen to have caused a wheeled robot to simply roll back slightly. The fitness curves all begin to converge, with the legged fitness curve converging quite well, showing that fitness is being taken into account with evolution, and evolution is properly functioning. The results of evolution, shown best in the wheeled robot, show that forward locomotion was achieved. The difficulties included in this project were the hardware limitations. I could not run as many generations as I would have liked to. I did not at first know how to fix terrain to the ground with hinges, so the terrain would be pushed by the robots, skewing the data, and clipping. I did not know about collision groups until week 3, so the robots themselves would clip into themselves and would not clip into the terrain. Well, would clip through the terrain, they would not collide with terrain. Fixing these helped the experiment run. Expanding in the future, more capable equipment to run higher number of generations allowing us to get a better image on the data. And procedurally generated terrain covering the ground, just more realistic terrain so that the experiment that we run can be more valid and tell us more about how these cross the reality gap, these 3 species. Thank you.